So one of the reasons that I really love working at Cisco, and probably, certainly one of the reasons that I've been there so long, is that every few years, just when I start to get a little restless, a little bored with doing the same old thing, something new comes along. And so right on schedule, about 3.5 years ago, I started working in a new group. And so I sat down with my new VP one day and said, what should I be working on? And he said, well, you can help me with a problem. And the problem is, I've been doing the rounds. I go visit our big customers, especially our big web customers, and they are having trouble with our boxes because they are incredibly data-driven, right? And everything they do, they suck up a lot of data and they analyze it and then they take action based on that data, except when it comes to networking. They have trouble getting the data that they want off of our boxes. And he said, so, why don't you look into that? And then he left. And that was my charter. And so I do what I always do. I started talking to my buddies in engineering. And I talked to a guy who told me to talk to a guy who told me to talk to another guy. And he said, the fourth guy I talked to said, you know what, I think we can do something about this. He said, I've been thinking about this, and I would love to do this. So together we worked up some slides. His team put together a demo in a couple of weeks. And I went back to the field and I said to the account teams, I said, what do you think? Any of your customers want to see that? Somebody said, come show it to my customer. So we showed it to the customer, and they looked at it, and they looked through all of it. They stopped right there. They said, that's what we want. We showed them the demo. They said, I want that demo in production. How soon can you have it? And that was the beginning of telemetry. And I think with those facts in hand, we could legitimately call it a skunkworks project, right? It was certainly small, since it was me and a couple other guys working under the radar. Definitely loosely structured, and we were, trying to do something that would be radically innovative. Now, some of you might roll your eyes at that, right? Because we're essentially talking about what we classically have called network monitoring. And if we were giving out awards for the most boring technology ever, I think that monitoring might qualify. So I know you've all signed up to listen to me talk for 90 minutes on telemetry. I bet none of you would ever have signed up for 90 minutes on syslog, right? Maybe, although a few years back, Facebook did a half-day seminar on exactly that, processing, at Danon, processing syslogs in order to do troubleshooting and remediation. But I suspect that not most of us would do that. However, it is a target for innovation because really, we have had problems in this area for a really long time, and I think they're well known, right? It's too slow. People poll SNMP at, 15-minute intervals, maybe? Some people get down to 5. It's incomplete. How many people here have ever needed a piece of data that was not in any MIB that was supported in their image? Okay? Right. So everybody comes across that, and then what do? You go to CLI, right? And then you start screen scraping, and then you start thinking, maybe I really should have learned how to use expect so that I could automate that, okay? It's also networking specific, right? We build tools that only apply to the network itself, right? Which means this incredible ecosystem of open source tooling that's out there and available to us won't work with most of our networking technologies. And that means it's hard to operationalize, right? It's hard to make part of the analytics and automation cycle. So today I'm going to do an introduction and recap. This is supposed to be kind of advanced topics, so but I at least want to give you a 20-minute introduction. If you came into my session last year, this is sort of a compressed version of that. And then I'm going to focus a lot on scale, because from that idea that we had 3.5 years ago, telemetry now runs in some of the biggest networks in the world, and in those same networks, they have turned off SNMP in favor of this technology. So we've learned a ton about taking this particular capability to scale. Say a few words about security, a very few words about troubleshooting, because I know that's a topic that'll put us all to sleep. And then I want to talk a little bit about use cases. What are the first things that people have started applying this technology to? Also, give you the opportunity now as the grace period to leave if this actually is not the session that you wanted to be in. We're going to focus today on the router side, on the device side, not necessarily so much on the collection side, and particularly on iOS XR. That was sort of the birthplace of telemetry, and I think where we've made the furthest progress and have the most understanding of how it works in the real world. There was a great session earlier today in DevNet by my buddy Victor over here, doing lots of demos. So if you want to see a lot of hands-on demos, he told me he'd be willing to show those demos to anyone. Victor, you want to raise your hand? Yes, he would be willing to show you any demo that you want to later on, so check in with him. Tomorrow and later in the week, there'll be some focus on our open source toolchain reference architecture for consuming telemetry. So if you're interested in the collection side of telemetry, Christina? Yeah, so these guys back here are going to be giving some labs and sessions on that. If you're interested in other platforms, XC and NX or even WLC, you can find sessions about all of that material here as well. All right, so you guys are still with me? Okay. So the paradigm and the idea that we started with is that, routers are amazing in terms of what they measure and the data that they collect, but we make it really hard to get it off the box, right? And so the big idea was to say, let's get as much data off the box as we can, as fast as we can, and in as usable a format as we can. And we wanted to get it off the box because we know, well, maybe you know, storage and compute on a really expensive router is really expensive, right? And there's much cheaper storage and compute available in data centers. Get the data there, and then you can run your analytics there. There's some arguments against that philosophy, but that's the philosophy that we started with. So I always say that there are three enablers for telemetry, three pillars of this technology. And actually, it started out with two, okay? And those were the first two. When we were working with the engineers and trying to think about, how could we improve performance? Performance was our #1 priority. And looking at the code, looking at how SNMP works, one of the things that was most apparent is what's killing us is the pull model, right? When you do an SNMP get and you have a reply, and you're doing the same thing every 15 minutes, every 5 minutes, you're wasting bandwidth by doing the query. And you're putting an additional burden on the router by having to, at random times, answer a query. How much more efficient it would be if you could just scoop up the data that you want in the router and send it out at the interval that you wanted. And by that one thing alone, we knew that we could just vastly improve the performance of getting data off the box. The other thing is that, I don't know how you guys feel about compiling nibs, but it can be a little painful, right? It's maybe not for the amateur or the faint of heart. But we wanted to start producing data that was ready for the tool chains and the frameworks that were out there to consume data, right? So let's make it ready for analytics. And then finally, we wanted to, so those two were the first two, and those were the things we took into our initial demo. And our first customer, we kind of blew their socks off by showing them that we could produce analytics-ready data at a speed that SNMP couldn't even pray for. Then they came back and this is what happens when you give people what they want. They come back with more requirements. They said, that's really great, but I would like to see that data modeled in a way that makes it more consumable for my automation. And data models are kind of foreign to network engineers, but to software engineers, it's really important if you know how your data is structured and what the type of that data is. So that was the third pillar, to be data model driven. And I'm going to sort of go a brief view of how telemetry is configured on and what it looks like to the router, but I would say there are three parts to telemetry, what that looks like on the router, and they map pretty well to those three pillars. First of all, we have a concept of a sensor group, which tells the router what data to stream, and those sensor groups are defined by data models. So that's the third pillar. We have a destination group that tells us where and how to send the data, and that's about making it analytics ready. And then we have a subscription, pulls it all together, that says how often. Let's look at that in just a little more detail. Sensor group is what do we want to stream, defined by data models, okay? So this is a sensor path, and that thing in bold is a Yang data model. How many people here would say they feel very comfortable with Yang? Okay, so a very small group of people. And what I really want to emphasize to you is that you could take can't type and talk at the same time. You could, in fact, take multi-day classes on Yang. There are many, many sessions here about Yang at this conference, but you don't have to know that much about it in order to actually use it, Okay? So I'm going to tell you everything right now that you need to know about Yang to use model-driven telemetry. Okay? If you have a browser, I will be fine if you open it up right now and you go to GitHub. Who here has a GitHub account? Okay, good. More people. You should get a GitHub account if you don't already have one. And because all of our Yang models are on GitHub. Okay? So you can go to this address right here. And if you want to follow along, that would be great if you do that. And if you see down here, I'll tab through really quickly. I go to vendor, Cisco, XR, and 631. This is a list of all the Yang models it will come, yes, that are supported on our XR platforms in release 631. Okay. Now, you don't want to click on this because it'll get kind of scary because Yang is very verbose, and then you'll start freaking out and thinking you need to go to a whole week-long seminar on Yang. Okay, but you don't need to do that. Right? The thing about having data models is it means that you can work with data off the box. Okay, so that's the power of it. So one thing you could do, if you are following along with me, you could do a git clone and go back to our repo. Have you guys done this before? Does this seem familiar to some of you? Okay, well you have, like Christina, don't even tell me that. Okay, you can go here, you say clone or download, you copy that, and then it'll start cloning, and I'm going through a bunch of VPNs. That'll bring all of the models down to your box, right? And I'm gonna let that run because I already did it earlier. So once that's done, you'll get this tree structure, which contains all the Yang models, and then you can start to play with them, okay? The only tool I use, there are a bunch of them out there, the only one I use is an open source tool called PyYang. But first, let's look at what models there actually are. Okay. So iOS XR, we divide our data models into two. We have config data models and oper data models. The oper data models are for operational data, okay? And those are the ones that telemetry cares about because we're streaming data off the box. There are almost 200 of these operational models in the latest release, and they look like this. And if you look at the names, you can see they do everything from AAA, data about AAA, and then at the very end, about WD Sysmon. So if you're wondering what is in this model, like what is the data that that model describes that I might want to, that's when we use our PyYang tree. And I use the tree option, and this gives me a tree version of all the data that's in there, okay? So does anybody recognize that data? What would be the command, XR command you'd usually get from that kind of data? Yeah, show proc CPU type of stuff. So you're looking at the total CPU utilization and process CPU. So that's about it. That's about as much Yang as you need to be able to do. There's a couple other PyYang tricks that are fun and help you navigate the models, but not much more than that. Because all you're really trying to do is find the data that you want to stream. All right, so as I said, we're adding new operational models with every release, almost 200 in our latest release. This is an example of PyYang, which I just showed. This is for interface statistics, but Victor said he'd kill me if I did another demo of interface statistics. But this is just for your reference, the sort of things you would see in a show interface command in a Yang model. And just notice a few things that this Yang model tells us. It tells us about the structure of the data, but it also tells us data type. Okay, we know when we get a generic counters that is an unsigned 64-bit integer. Okay, that's an important piece of information for a software developer who's writing an application to consume that code. I think one of the hardest things about using telemetry is to figure out if you have in your mind show commands, right, or if you have in your mind MIBs, how do I know which data model has the data that I want? Now, those of us in the room, I showed you people you can go ask questions of. We've done this for a while. We have collected a list that will help you get started. As I'll talk about later, the #1 use case for telemetry was as SNMP replacement. So a lot of the work that we've done is to map the paths that go to the SNMP MIBs that most people are likely to use. So these are for your reference. You can forget about this until you're actually trying to deploy this and then come back and see if the thing that you want is in this list, okay? So information about the system, about the RIB, about BGP, and then all the 180 other paths that are out there. Something that's really important about data models, and I know this is, I'm sorry, I feel like I'm torturing you with data models. They are really one of the most boring topics, but you know, I warned you. So one of the important things to our customers that they came back to and said, we want that third pillar, is that they're not just for monitoring data, right? All of us, we grew up on the idea that you configure, usually using CLI, and then you get your monitoring data using something else, using, you know, syslog and SNMP, and if you had to, CLI. But really, there's no reason that you shouldn't have the same language and same way to model your intended state and your actual state, right? So your configuration and your operational data. So one group of folks that was really big on that was the Open Config Consortium. So Open Config is a operator consortium led primarily initially by Google. And when they defined their models, right, they went off and said, this is the kind of model that we want, and then came back to vendors like us and said, now you implement our models. I don't want your old native models, I want this model. Which I think is a good idea. It gives us, you know, cross-vendor consistency. But one thing that they did that was quite interesting, if you notice here, see how some of those start with RW? That's read-write. And some of those are RO, read-only. So they actually think that it is so important to use config and operational, the same modeling language, that they even put it in the same model, okay? So the open config model uses one model for both config and operation. But whether or not you use that, the concept is important. If you understand these Yang models, you understand the same Yang models that can be used for configuration using Netcom for other technologies, okay? So I think we need to get more in the mind of thinking about these are not two separate domains, but they're related, because the whole reason we monitor the network is that we get data that we can run analysis on the data and then use it in turn to modify the state of the data. All right, second piece, that was the first pillar, well, it was actually the third, about data models. The second one, where and how do you want to stream that data? This is done by the destination group. You can have multiple destinations, you can do IPv4, you can do IPv6. I'm going to talk about the encoding in the next section, so I'm just going to go over that for now. You can choose the transport that you want, right? We support TCP, gRPC, and UDP as of the latest release. And there are two sort of broad conceptual ideas you should have about it. One is the idea of dial out. And this is from the perspective of the router. When I'm ready, I am going to dial out to the collector. If it's TCP based, I am going to send the SYN packet. If I dial in, I'm going to be sitting here waiting as the router with my port open, and the collector's going to dial in to me. In some ways, the significance of dial in and dial out is you know, it can be about security, like where you want to put your ACLs. Some people find it more difficult to dial into the box than to dial out based on their existing security policy. But once it's done, it doesn't matter. The functionality is the same. The router scoops up the data and pushes it out. There's no sense, after that initial SYN packet, there's no query coming in for that data. The security piece of this, which I'll talk in more detail later on, is that if you want security, if you want encryption, you must use gRPC. So I'll talk about that in a later section, but it's worth noting in your mind. Just if you care about encrypting your monitoring data, gRPC is your friend, and you'll get to know it better. The last piece that ties it all together, that how frequently it sends it, is the subscription, and you just combine that sensor group with the destination group, and then say how often. In this case, it's 30 seconds. I'm going to take that data and send it out to those destinations every 30 seconds. This is important for scale as well, because how you define the subscription determines how the internals of how the router will internally process that and allocate CPU resources to deliver it. I told you we're going to focus on the router today, right? I love routers, but it's also important that once you scoop up that data and shove it off someplace, you have to consume it, right? So what I talk about most often is an open source reference architecture. This is what you'll see in the demos in World of Solutions, in DevNet, as well as in the lab that we have later this week. This is a set of open source tool chains here. Pipeline is something that we open sourced last year. It terminates, say, the gRPC session. It takes in the data, and it can output it directly to a time series database like InfluxDB. It could also put it on a Kafka bus. Are you guys familiar with Kafka as a pub sub mechanism? Okay. You could use on top of InfluxDB, for example, you could put Grafana. You could use alerting tools. There's a whole ecosystem out there that you could use on top of that data. I also have a buddy here. He promised to have it ready for this week. He didn't, but he is going to publish shortly a tutorial on going from Kafka to Splunk. So you can use open source tools. If you love your commercially supported tools, you can use those too, as long as we can integrate through something with Kafka, like Kafka. All right, so this next fairly long section is going to be about scale. Okay, so these are real life issues that we ran into and had to figure out ways to get around. So telemetry, I think, as I said, initially the whole idea was let's get as much data off the box as possible. So we want to get rid of computationally expensive things on the router, because if something is computationally expensive, it also slows us down. And so the functionality was optimized for bulk export, because we can get a lot of efficiencies if we just go in and grab a bunch of data and send it to you. Even if you don't want all that data, it's better for you to filter it than for us to try to pick through it and send it off to you. There are counter arguments to that device, but that is the one that we went forward to, and I think in many cases it holds true. Better to get you too much data too fast than too little data too slow. Now, I think it's possible to have too much of a good thing. These are my daughters, and of course you cannot have too many cute kids in your life, but they also collect these things called Beanie Boos, okay? And they regularly beg me for more, and right now we have 87 in our house. And they're really cute and they're really sweet, but 87 is too many. So like Beanie Boos, it's also possible to have too much data. And let's have an example here. So how many people here would be interested in MPLS TE operational data? Anybody doing TE? Okay, so a few people. This is the Yang model that you'll want to use. However, if you go through that Yang model and you count the leaves, right? The leaves are the end part of the container that actually contain the values that you want. If you go through and count it, you will find that there are over 40,000 leaves in the model. And that's not even counting the fact that some of those containers are repeated per tunnel. So let's say you have a couple thousand tunnels. Multiply that by 40,000, it's a lot of data, okay? Are there Python programmers out here? A few of you. I just want you to note the beauty of Perl. At the command line, okay, this command sorts through that entire text file and finds just the leaves. We count them. So the important thing is know what data you really want, all right? If all you really care about is the number of AutoMesh tunnels that are up or down, there's actually a container for that, which has 6 values in it. And you can you can sort through your data using a tree path to get those 6 values. So that's a tip. Be as specific as you can in what you specify. If you only want 6, specify the 6, don't specify the 41,000. And that, in terms of configuration, means do what's in the green, not what's in the red. Okay, the more specific you make the subtree path, the more specific data that you'll get. And this will really matter, especially when you're talking about a model with 40,000 leaves. The other thing that you can do using models as a sort of crude form of filtering is use the least common denominator, which in this case would be the open config model. Okay? This one has, with oper and config all told, 230 leaves. Okay, that's much smaller. So on the other hand, it may not have all the data that you want. You should look through that model, and if there's something that's not in there, then you'll be reduced to using the bigger specific model. Okay, everybody clear on that? How you can sort of use models to start filtering down the amount of data? That's very helpful for scale. Let's talk encoding. So encoding is this idea that you have data on your router. Okay, it might be in an ASIC in a register someplace. It might be in a table in your RIB, in your FIB, BGP neighbor table. You need to get that data off and put it, serialize it in a way, put it on that can be put on a wire and transmitted so that the receiver can decode it and use that data, have an identical copy of it. Does anybody, what encoding does netconf use? Anybody know? XML, okay. So netconf uses XML. It encloses everything with these opening and closing tags. That is one way to encode. It's not particularly efficient. There's even a website, a URL, I hate XML. So, you know, some people love it, some people don't like it. So other encodings, we don't support that on XR telemetry because, as I said, our initial goal was to be as fast as possible. We support 3 other kinds. The first is JSON, okay, JavaScript object notation. If there are any Python programmers out there, if you've done RESTful APIs, you've probably come across JSON. It is a series of key value pairs, and everything, it's full of strings. And I say this because strings, text, is really hard. There's no computer language really ever invented that deals with strings in a super efficient way, and it's hard to compress it in such a way that it goes across your network really efficiently. But it's nice for human beings to read, right? You guys could sort of squint at this and figure what it is. The stuff in red is metadata. You have some keys. It tells us what the interface name is, and then keys and values on the side. These are basically interface statistics, right? Interface rates, sorry. So this is a nice way for human beings to look at the data, but it's not particularly efficient. The most efficient option that we started with was something called Google Protocol Buffers. Are you familiar with that? Okay. So it's some people. It's binary, okay? So it's binary encoding. It's not friendly. The reason I didn't show you a screenshot is there's nothing to see. It's just a bunch of gobbledygook, right? On the other hand, it's very simple for developers. It's very fast, and it has a lot of compatibility built into it. And so what the difference is, in order to encode and decode, you need what I call a decoder ring, and that's called the .proto file. We support, I know you guys are like, okay, that's great, and now I'm going to tell you we have 2 flavors of it. So the key thing to remember is we have a very compact version that's incredibly efficient, and we have what's called a key value or self-describing version, which is slightly less efficient. I think when we first started working with it with the development team, there was kind of a little joke that we called this the I can't believe it's not JSON encoding, because it's similar to JSON in that it sends its keys as strings. Strings are not efficient. Just remember that. If you use the most compact version, we send the keys as binary values. If your collector receives a binary value, it needs a decoder ring to know what that actually refers to. We have a .proto file here on the right that corresponds to the Yang model. You need a proto file for every Yang model that you specify in your sensor group. Okay? So if you are streaming data from 198 different Yang models, you will need 198 proto files to decode them all. This is the important piece that I want you to take away in terms of, as you're looking at your different options about performance. So this is a scaled up system. It was, 2,000 interfaces in this one? And over 700,000 routes in the RIB on the system. And as you can see, if we look at the interface statistics, you can see for each collection, if you're doing it with JSON, it takes 2 megabytes. Every collection is 2 megabytes to suck it off the router and encode it and put it on the wire. If you're using the compact form of Google Protocol Buffers, it's 0.3. And then the key value, the self-describing, falls in the middle. Okay? And so depending on how many strings are in the output, you could have anywhere from 4 to 10% performance hit going anything other than compact protobufs. Okay? So the trade-off is you have a lot of protos to manage if you're going to do the compact version, but your performance is pretty killer. I will say that at first this seemed like a big hurdle to me, and I thought nobody will use compact. I don't even know why we did it, except it's the most super efficient thing we can do. That was the initial one we did to the customer that knocked their socks off. But over time, I think this will change. If you use Pipeline, which is our open source collection tool that's in GitHub, Pipeline includes all the, or most of the protos that you need. I'm not sure if we're up to date for the latest version, but it includes hundreds of those proto files. So it will take care of decoding the compact stuff for you if you need to. All right, any questions about encoding?
Is there any reason you would ever have asynchronous versions of your proto files? Doesn't just clone away with whatever you're running and just kind of sit there?
So would there ever be any reason that you'd have asynchronous versions of your proto files? And it could be, because say you take a pipeline as it is today, and then you upgrade to, in the future to 6.7.1, and there are new models and therefore the new sensor paths that you can encode. So you would have a different set of protos. You would have the new ones here and the old ones there. And all that would mean is that your collector couldn't decode the new ones. until you uploaded those to your collector. Anything else? All right, so that was encoding, all right? So you can get really efficient, and that'll help you scale. The other thing that's new that will help you scale is something called event-driven telemetry. I don't know, as I talked about my kids earlier, and I don't know if any of you guys have this experience, but I get a lot of things where my kids ping me, like, Mom, 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 Mom. Do you guys get that? Okay. And most of it's just like noise, like they're kind of checking to see where I am in the house. Mom, Mom, Mom. And every once in a while there's a Mom, right? That's the important one. That's the event, right? Someone hit their sister over the head with something breakable. So that's sort of the difference between our first version of model-driven telemetry and then event-driven telemetry. So if you were watching the animation as it went by, the way we have it today, if you were looking at interface state, you would just every, say, 10 seconds send off, I have 100 interfaces up, 0 down. And then after a while, an interface would go down, and you would send 99 up, 0 down. And you would send that same message forever, every 10 seconds until the interface came back up. How much better it would be is if you got one message that said, all my interfaces are up, and then at some point in the future, when one of those interfaces went down, you would get one message saying that my interfaces are down. So that's the idea behind event-driven telemetry. And again, this is one of those, maybe I should call it the fourth pillar, because it's the fourth thing that our customers came back to us with to say, look, I don't need 10,000 up messages. All I really want is to get the state transition. So you can use this today, and the way you configure it is you just set a sample interval of 0. And that means you only get that if something changes in that data model, the router will send it to you. So here are some sensor paths that are supported for it. The initial ones that we got our feedback were the highest priority. Obvious things like interface state changes, right? You want to know when an interface goes up or down. Another one is a rib, right? If you remember those numbers from before, if you have hundreds of thousands of routes in your rib and you're trying to get that whole thing out, that is a lot of data. It just takes a long time to scrape that data off the box. So how much better it would be if you can get it once, the whole thing, and then only tell me when something changes in the rib. Okay, so that's why that one became a priority. And then sort of a catch-all we have is syslog. You can put all your syslog into events telemetry as well and send it over that same pipe. I'm curious, are any of you, just to put your thinking caps on for a second, what are other kinds of data that you would be interested in having for events? You don't have to tell me now, you could tell me later, but I really would like your feedback if you're thinking about helping us prioritize what would be the most significant things. Anything come to mind? Changes in the IGP state, not just the rib, but the actual IGP, itself, okay? Anything else? I mean, I know generically state changes, but it's helpful to know which, LLDP is one I've heard, right? It's good to know when your neighbors come and go. Interface timers, I think, okay. Okay. Optical is another good one for alerts. I think, what's interesting about this is if you go to any of the demos that we've talked about, you will see examples of alerting, right? These are events, but they're calculated on the collection side, not on the router side. We're actually using up some router resources here because it's valuable to do that, to filter the data in this way. Okay, good? All right, how you guys doing? I know it's rough, isn't it? You're like, wow. Scale is one of the most boring topics ever, but if you're trying to do it, it can be incredibly frustrating if you don't know these things. So let's talk about multi-threading. This is a simplified version of what telemetry looks like inside the router itself, okay? So we have a process, a daemon called EMSd, Extensible Manageability Services, okay? And that's an internal detail that you may never care about, but it puts together these processes that include gRPC, it includes our ultra-efficient encoder, And then a bunch of threads, right? So threads are little units of execution that can go to the CPU that makes it look like it's processing things in parallel. And those collection threads are what goes out to the ASIC to get the data, that goes out to the BGP table to get the statistics, or the CPU to get those statistics. And here's the key part, right? Well, if you ever want to get data about the process, telemetry process, it's show process EMSd. Okay, so there's a bit of trivia for you. You look cool. You can't do a show process telemetry. It's show process EMSd. Most of this means nothing to you. It might mean something to the TAC engineer who's helping you, but the one piece in the corner is just what I want to point out to you. You get a thread. You get a separate unit of execution for every subscription that you configure on the box. Okay, so I have 3 subscriptions here, and there are 3 threads. Why do you care? You're like, we're not software engineers. I don't care about threads. I heard about those once. But let's talk for a second. We shipped with single threading. Okay, so this is actually how the very first versions went out. And this is what would happen. If you had a well-behaved collection, the collection would begin. The EMSd would do its thing. It would go off and collect the data. Maybe it would take 10 milliseconds to scoop up all that data. Right? It's not instantaneous. It does take some time. And then it would send it out. Right? And then maybe 10 seconds would go by, and then it would do the whole thing all over again. Right? So that is a well-behaved collection, and each bag of data is sent sequentially. So power user tip. This is something that came out of one of our first production deployments, is that the way we initially did it is that the collection would start, and then the collection would end. And maybe that would be 10 milliseconds. And then the sample interval would start as soon as the collection ended. Okay? So if you set it to 10 seconds, it would start there, and then it would go till 10 seconds and start the next collection. So what start-to-start timer would be 10 milliseconds plus 10 seconds. For some time series databases, this causes a problem. So what we introduced was the option to make the interval strict, which would mean start to start was exactly 10 seconds. It would not include the collection time. Again, just file this away in your library so that if you're finding weird things with your time series database, you can remember that the strict interval is an option for you. All right. So now we know about our collection intervals. Large collections can cause you problems. So what's the large one that we saw? Like the rib. Okay? That is a big honking piece of data coming across. So let's say that, again, our collection begins, and it goes out there, and it takes a long time to get that data and encode it. And maybe that's 13 seconds for a really large rib. And then it encodes it and puts it on the wire. But if your sample interval is only 10 seconds, well, clearly you're not going to finish in the 10 seconds. But also, what if you have something that's backed up behind that, right? What if you have remember that tiny little data model I showed you? The WD Sysmon one that just had the CPU stuff in it? What were there, 12 values in there? That's very small. That can be collected really quickly in milliseconds. But it's queued up behind this big collection, right? Anybody remember the good old days of voice when we had little tiny voice packets queued up behind big fat data packets? And we had to chop up the big data packets in order to interleave the little ones? Well, it's kind of a similar thing, except it's with processing. Essentially what we're doing is we're delaying the collection of the little thing till the big thing finishes. And this is not a great thing, because why should I have to wait 15 seconds for my CPU stats when I can get them in 10 milliseconds? So that's one of the reasons we introduced the idea of multi-threading. So now essentially what we can do is kick off both collections at the same time. Okay? So you can send your request out for the CPU and the rib statistics at the same time. The way that you do this is you put each model in its own subscription. Remember back to I was showing you the subscription configuration at the very beginning? So you need to, if you want to utilize this capability, make sure your big model is in its own subscription. Make sense? Yeah, okay. All right, so I was going to say a few words about QoS. Actually, QoS really isn't about scale. I mean, sort of. You could stretch the argument to say, so you can prioritize traffic in times of congestion, but I didn't want to have a whole different section for QoS, so I just stuck it in this section. Starting with 622, does anybody use the feature in SNMP where you can DSCP mark your SNMP packets? One? Or you just moving your glasses? Okay. So maybe a couple people do that. Well, you can do that with telemetry as well. So You can set the DSCP value on the telemetry packet, and that'll give you some control on how that packet is treated in your network as it goes through the network. Okay, and here's a screenshot. Everybody loves a screenshot. Yes, the DSCP is marked as I configured it. Last thing I want to say around scaling telemetry is I've talked a lot about these sort of really deep down internals about the router and how the little things you have to know to make it perform its best. Obviously, once you get off the router, you really have things to worry about with scale. Okay, where are you going to put that data? Pipeline, the utility I told you about, scales horizontally, but then where do you dump it? Do you put it in InfluxDB, Prometheus? Do you put it in Elasticsearch, OpenTSDB? Do you put it in Panda? There's lots of options for where that data can go. And this is a whole separate presentation on its own. This is something that, you personally probably aren't going to decide as you develop it for your organization. But you should know that there are comparisons between where you put that data. And you need to make sure that this can scale to the kind of data that you're sending it. There's a whole other issues around data retention. How long do you want to keep data? Do you want to aggregate it? How long do you want to store it? These are all important issues, but I'm not going to deal with them because that's a collection problem in my mind. But this will get you started if you want to do your research on, what kind of, and these are just for open source platforms. Obviously, there are lots of other options. We've shown integration with SignalFX and Splunk and other tools as well. So if you don't want to worry about that, you can outsource that to someone as well. That's scale. Questions about scaling telemetry? Okay. Has anybody really grappled with issues of scale in telemetry? Or, okay, a couple of people here. All right. Question?
Do you have some information about how particular encoding affects performance in terms of scaling?
So encoding in terms of performance is, it's not really an issue. I don't think we've seen anything with that, Victor, right? The differences. Actually, Victor did some testing recently. He was doing 300,000 metrics, 600,000 metrics every 5 seconds, every 10 seconds. Oh, so I knew I had that somewhere. So 600,000 metrics, 600,000 numerical values about the state of the router every 10 seconds with a CPU hit of about 8%. Okay, so you can get a lot of data off the box really quickly, and impact to CPU is, I mean, it's not nothing, but it's not. Try to do that with SNMP, and you'll kill the box. All right, so let's talk a little bit about securing telemetry. This is probably the 5th pillar of telemetry, right? So, we started with performance, analytics-ready data, data models, scaling, and then what came to us is the issue of security. So when we were trying to go as fast as possible, we didn't give it a thought, right? You just scoop up the data and you throw it you put a header on the packet and you send it off as fast as you can, as often as you can. And that's true of UDP, and that's true of TCP. Okay, so you configure the router and it will just start sending packets to whatever that destination is. So if you configure gRPC dial-in, okay, I should say a few words about gRPC, okay, because I don't know if you guys are familiar with it. Are you guys familiar with HTTP 2? The replacement for HTTP 1.1? Okay, so it's very similar, except that gRPC is basically a blob of binary. It's a Google protocol buffer inside HTTP 2. But it brings along with it a bunch of features. So when you do gRPC dial-in, when the collector is dialing into the router, the collector sends that send packet and it does an HTTP setup. It needs to send a username and password to the router in order to access the router. We're trying to protect the router a little bit. I think it's kind of a joke if you're not doing TLS because the username and password is sent in the clear. There's nothing to protect the credentials themselves. This is, again, a power user tip. If you're doing gRPC dial-in, the username must be one of these, part of one of these groups, okay? Sysadmin, netadmin, or root LR. If you don't want to put them in one of those groups, you can define your own with this task group here with all those items in it. Okay, you guys familiar with task groups, or are you mostly like XE folks? Okay, all right. If you want to do any kind of protection of your data, you have to use TLS. I'm sorry to tell you. And that means you're going to have to deal with certificates on your router. How many people have a PKI that they issue certificates for all of the routers in their network? Okay. Couple. Okay, so this won't scare you at all. The only thing to remember is that in gRPC, the client validates the server. And this is the same if you're in your browser, right? You, the browser, will validate the server. And so you validate the server certificate. And in this case, what it means is that the router is the server, so it's the router certificate that is validated by your collector, by your client. If you want to try this in the lab, the simplest thing to do is just to, when you configure TLS under gRPC, it will auto-generate a self-signed certificate from the router. Okay, and you can find it if you drop into the bash shell, it's right there. And if you, and I don't know if you guys have tried dropping into the Linux shell on XR, but you can use all of the familiar, if you're Linux folks, you can use the familiar tools like OpenSSL to examine that certificate. And in this case, you can see the issuer is EMSd.cisco.com, and the subject is also EMS.cisco.com. Okay, it's a self-signed certificate because the issuer and the subject are the same. So I think this is a reasonable thing to do in the lab. Again, if you're serious about security, then you're probably not using self-signed certificates. This is an example from Pipeline, our open source utility tool. And as you can see, you have to have a copy of the certificate locally, the CA certificate, and specify the TLS server name there. Okay? And if you're not using Pipeline, then do something similar for whatever collector you create. All right, so how many of you have actually configured telemetry? Has anyone configured it, used it in the lab? Okay, so a couple, 3 people. So this will be familiar to you. This is the command that you use to validate your subscription. And as you can see, what you want to see is that the state is active. It assigns its own dial-in group name, so that's 1006 here. And you can see TLS is set to true. That's what you want to see for a successful dial-in with TLS. You can also do TLS with dial out, but you have to remember that the client and the server roles are reversed in this case, right? If the router is dialing out, it is the client. It needs to validate the collector's certificate. That means the router must have a copy of the collector's root CA certificate. This is PKI, TLS. If you're familiar with that, it's easy. If you're not familiar with that, you're going to feel some pain when you do that. Whether you do dial in or dial out, once you've set up TLS, your data is encrypted. If you're really going to do this, I wrote a series of a very detailed tutorial on this. It uses self-signed certificates, but at least it can get you started. It uses all standard Linux open source tools to generate those certificates, but you should be able to get going using this tutorial. How many people here use SNMP v3 in their networks? Do you know? Okay, so a couple people. So you might be, are you doing encryption with SNMP v3? Is anybody doing encryption with SNMP v3? Okay, so you may not care, right? If you're not encrypting your data already, you know, if encrypting monitoring data is not an issue for you, then forget everything I just said, okay? I think where this becomes maybe more interesting is if you're sending monitoring data off your network, right? So we did a demo last year with SignalFX, which is a cloud service provider of real-time analytics. And that means that we're sending data out of our network to a cloud provider. You may want that data to be encrypted. Yes, so the question was, does XR send the data out of management interface? And we'll get to that because it gets really complicated. Okay, yeah, so I have a section on that, but yeah, it's a good question. Actually, I'll get to that very soon now. Okay. So I know troubleshooting, it's like, it sort of seems interesting when you're reading the abstract and deciding if you want to come to the session, but then you get here and you're like, oh my God, she's really going to like drown me with CLI commands and, you know, workflows. So I had a big section and I made it a lot smaller because I know how painful that is. So let me just talk about 2 common problems that we see with troubleshooting. And the first is around the models and the sensor paths, and another one is about the transport issues that you were asking about. Okay. So the first thing you want to do is make sure that your sensor paths are resolved. So if you remember, we specified our sensor path as Yang models with subtree paths behind it, behind the colon. And what internally happens is the router takes that and it translates it into internal data structures. And if it successfully takes what you put in and found an internal data structure that matches it, then you get resolved. Okay, that's a good thing, and that's what you want to see. If you see that it is not resolved, then your telemetry will not work. And there's two common problems that you'll come across. The first is that the model is supported, right? So we saw before, this is the iOS XR shell util-upper model. That model is supported. But actually, let's have a look at that one right quick. Okay. All right, so you can see it over there? And I'll do it over here too. So we can ls, and what was it? Shell util. Oh, sorry guys, I never type well under pressure. I used to record my demos and then people would complain that I spent all my time typing, just having recorded demos, so now I try both. Okay, so here we go, and do you guys see this? This is the shell util upper model there. But if we do a pying minus f tree on that, you will see that it does not have a foobar in there, right? And oh, you can still see it over here. See how that colon foobar here? There is no foobar in there. And if, in fact, I try to do, this is another cool pying trick. This is really the only other pying trick you need is tree path. If I try to do foobar, I get nothing back. If I try to do what I know works there, system time, then it will give me the full tree path there, okay? So this is how you use your offline tools to validate what will work with telemetry in the model itself, okay? Question? Yeah, that's a really good idea. Why don't we do that? Yeah, no, I think it's a great idea. We should do that. We don't. I think we have a bug we should open, don't you? Yeah, okay. Yeah, but then what would we do during the troubleshooting session here? And how, you wouldn't be an expert. You wouldn't, this is job security. You come here and I empower you for job security. Nobody has ever asked me that question before. Thank you, that was so lovely. Oh, Einar, do you have anything to say about that? Oh, Einar, in the back here is our Yang models expert for all of Cisco cross-platform. Okay, all right, he's gonna fix it. That guy right there, I'll give you his email address. Thanks, Einar, I appreciate it. Okay, so the other example is, in the second one that we see down here, I've said iOS XR dash foobar, and if I try to look for foobar in my directory, you will see there is no foobar model, so it can't be resolved. Okay, so those are the two errors that will cause your sensor path not to resolve, and there's no data on the box that supports it. Okay, so let me change the other screen over too. You guys should be able to see too. All right, so this is what you want to see, okay? When you do that show telemetry model subscription, you want to see that your subscriptions are active. That in blue, that is happy state. And you'll see both that the overall subscription is active and the destination group is active. You can see we're talking to a collector at 1030.1114 and on that particular destination port. Oh, and look here, this is dial out. I'm using TLS. And under TLS, you can see the common name and the certificate of the collector that we're talking to. I didn't give you an example of that before. So this is an example of a successful TLS, gRPC with TLS dial out subscription. Okay, so this is sad. This is sad state for telemetry, right? The state is in A, that means it no worky. It probably should be in W, no work. Again, this is a dial-out example. We're going to a different destination IP address, and we're not able to connect. So you're all good network engineers. If your router cannot talk to a server, the session is inactive. What is the very first thing everyone will do? Ping, yes, of course. We love ping, right? So let's say that I go onto the device and I ping the collector. And I ping that same IP address and it works just fine, okay? So I have connectivity. What if, are any Linux folks here, IT folks, what do you do if you're trying to check to see if your application, your utility is listening on a and so, yeah, or SS, right? Are different Linux utilities for checking, so you check that. And if you're familiar with Linux, you know this, that we see that pipeline is in fact listening on that port that I'm sending to. So now what? That was the obvious. We're listening on the right port, we're pinging from the router and it works. So then what do? You do what? Ha ha ha. Okay. Ping from the management interface was the suggestion, or the management VRF. Yeah, okay. So here's the non-obvious thing. And as my daughter would say, some people look at this picture and go, right? It's kind of a little bit mind-blowing. Oh, I have a question there. Can I send it to what? Can I send my dial out to a multicast group? You can't do a multicast group, but you can specify multiple IP addresses in the destination groups. Okay. Did you say 2 questions?
No, it's like using multicast address like
right.
It's maybe more effective than having multiple multicast.
Yeah, I mean, I guess a lot of the customers we work with don't use multicast in their networks, and besides that might that might be a function that you would more properly belong to something dedicated to it, like a Kafka bus. Okay, so Kafka provides some of that multicast functionality. All right, did I scare you with this picture? Is that why you're leaving? Look, he's leaving. He looked at this picture and he's like, I can't even deal with you talking about it. So you may not know this, but in 64-bit iOS XR, okay, some people call that EXR. We have sessions here at Cisco Live about this if you want to really dive deep into this. We run on a common Wind River 64-bit Linux kernel, okay? And XR now runs in its own, the control plane for XR runs in its own container, in its own LXC. That's a Linux container on top of that, okay? And so gRPC, however, runs in a different container, okay? Which is sometimes called a third-party application or a third-party container. This is only for 64-bit iOS. So if you are you using 32-bit? Yeah, I'm sorry, okay. So for 32-bit iOS XR, everything that I've talked about works except gRPC. Okay, so you don't have to worry about this. You will never encounter this problem on 32-bit iOS. Okay, so there's the trade-off. How many people here? How many people are using 32-bit? How many people are using 64-bit? Okay, all right. So good for you to know this stuff anyway. All right, one day you'll run into this. If you look at the third-party container here, what you will see is what it knows about is the management interface, okay? Its only access to the line card interfaces, right? All those other interfaces is through the XR control plane container, which is managed by something called the forward interface. Okay, so I'm going to try not to dive too deeply into that, but just take it for granted that by default, the gRPC only sees and only has access to the management interface. And gRPC, so it relies on the underlying Linux networking. So if you go into the top one, you see that looks like a familiar router CLI, and if you do the show IPv4 interface, you see both the 10.30.111 subnet and the 172.38 subnet. Okay, XR knows about that. The XR control plane container knows about both of those addresses. But if you look at Linux, if you drop into the bash shell, which now you can do on 64-bit, you can type bash and go into the Linux shell, you can see that it doesn't know, right? It knows the forward interface, but it doesn't know what address to associate with the forwarding interface, so it cannot forward out of that interface. So if Linux can't get there, if you drop into the bash shell and you cannot ping that destination, then gRPC can't get to that destination either. Let me just tell you, this is a really hard thing to troubleshoot, okay? This was a hard-won insight for me. So file it away in the back of your mind, come back to it later if you're, remember, Shelley told me about some weird Linux thing with gRPC. Come back to this later. You don't have to understand all the details, but as you see, if you drop into the bash cell, here, your ping is 100% loss, okay? So there is no connectivity between gRPC process and your collector, even though your XR container did have that connectivity. So what do? Always use the management interface, right? So that's one way to do it. Does everybody here use the management interface for management data? Okay, do people not use who doesn't use the management interface? Okay, okay, our first customers did not use it, which is why maybe I didn't realize this when we first shipped it. But for those of you who do use something other than the management interface for management data or for telemetry data, remember this. The other reason that people might not even know that this is a problem is because they have a routable loopback. How many people have a loopback that they distribute into their IGP that becomes routable everywhere in your network? Okay. If you have that, then that will be applied as the source interface, and that means that traffic will be able to leave and come back using that loopback. The other thing that you can do is configure a TPA source address, third-party application source address. Okay, this, if you're a Linux Linux person, this provides a source hint to Linux, so it knows how to route that traffic. So this is you choose the default, the VRF that you want to send it on, the third-party address, and then you say update source. You could also do an update source of a loopback interface, but on the other hand, it has to be routable anyway. Now, if you go and do that ping from Linux, it works, and now your subscription will be active. Okay, again, this only matters for gRPC, it only matters for 64-bit. Okay, so this is the summary. Again, I have a tutorial in nauseating detail if you forget this. It will reteach you all these things. There's also a ton of material on application hosting in general, so if you're curious about that idea and what it means to have third-party applications running in containers, then I've also given you the links for that on XRDocs. Okay, any questions around those general troubleshooting ideas? Okay, so I want to spend the last section talking about some things people are doing, right? I said I was going to focus on the router, but I think it's really important to kind of get your head out of, show proc EMSd and the Linux networking and sort of think about once you get all that working and it works at scale to the level that you want, then what do you do with it? I call this use case 0 because it really was why we started. And it's about SNMP replacement at scale. So we had customers who, and this is now three and a half years ago, I'll tell you, some of the best users of SNMP in the world that I've ever encountered are the big web customers, right? They have tuned that stuff, they have found bugs, they have forced us kicking and screaming to fix those bugs, and many of them are able to query things like interface statistics and QoS at 1-minute intervals, okay? I would assume most of you guys are maybe 15 minutes. Yeah, I'm getting some nodding heads. That's what, other sort of the norm is 15 minutes for things like interface and QoS. These guys, even with existing technology 4 years ago, were able to get down to 1 minute. But what they foresaw on the horizon was a time coming when we were getting higher and higher interface line cards, right? So we were getting denser line cards, more interfaces. More interfaces means that you got to get more data out of there. And if they were already, they had managed the CPU, but they were devoting a significant amount of CPU resources to SNMP at 1-minute intervals. They could foresee the day that they could no longer get the data that they wanted at the speed they wanted, even at 1-minute intervals, much less go any faster than that, with higher density cards and higher density chassis on the horizon. So it was a fairly urgent use case to find a replacement just to stay in the same place. Not to do any better data analysis, but just to stay in the same place. And this is an example of this. This is from summer of 2016. Google talked about this at an Open Daylight meetup, where their intention was to turn off SNMP in their network for exactly this reason. Sometimes people say to me, what's the use case for telemetry? And I'm like, well, what's your use case for SNMP? And I think that's one way to think about it. There's that as the very initial starting place is, what do you use SNMP today for? Are you hitting scale limits? Then, telemetry might be a good place to start investigation. This next use case was something one of our account teams was working on with their IPTV customer. And they had a managed IPTV service running over the core, and they were marking all of their IPTV traffic to give it into a dedicated queue. Today, they're doing SNMP polling every 15 minutes with daily roundups of the data and then analyzing it. Things are changing much more rapidly than every day in their network. And it's really important for them to be able to see packet drops because that directly impacts the quality of the thing that they're delivering. So in this proof of concept that we did for them, we used that open source framework that I was talking about for collection, collected the QoS data. QoS data, has anybody used the CBQoS nib before in iOS? How do you like that? Pretty simple, straightforward, easy to use? Okay, getting some laughter. QoS is a tough thing to get data off the box about, right? It's pretty complex. It's indexed in a weird way that you have to do complex interactions to get it. So QoS becomes a good candidate for telemetry. Anything that has data that's hard to get today is a good, beyond scale is data that's hard to get. So in this demo, we were able to use this sensor path to collect data about any dropped packets in the queue. And then beyond that, using all of these open source tools and plugins, we could not only just do simple visualizations like this is in Grafana, but you can also do alerts. So if you look in this picture up here, whenever the number of dropped packets crosses that red line, that generates an alert. An alert can then trigger a webhook that can go out to Ansible or NSO and cause it to reconfigure the box. And so what they did in this very simple demo is for that class DSCP4 where the IPTV traffic was flowing through, when you hit the alerting threshold, there'd be a webhook out to Ansible that would come out and reconfigure the box for more bandwidth. So it would stop dropping packets in that queue or drop an acceptable number of packets in that queue. Another place, and this is the subject of the LTR-NMS 1578, which is Friday morning, right? Yeah, your session's Friday morning, is around BNG, Broadband Network Gateway. Anybody here work on BNG? Okay, so subscribers, wireline subscribers, think about that. There's a lot of them, right? On your edge box, you're managing a lot of sessions. There's a lot of address management tasks. There's a lot of things going on and a lot of data. So again, here's a good use case for telemetry because there's a lot of data that's hard to get off the box in an efficient way. So this was a pretty simple demo, but it illustrates the concept really nicely around address management. So when you're starting to get towards the limit of your DHCP pool, then you can circle that back into data that can then come back and affect your network and change the amount of address space that you have. Another place that kind of surprised me, but is true in terms of interesting use cases, was around optical, right? And this could be for pluggables, but it could also be for platforms. Really day one, without creating a new MIB or finding bugs in MIBs, we were able to stream via telemetry all 4 lanes of things like transmit and receive power on pluggables. If you don't care, who cares about optical? Does anybody care about stuff like that? I don't know. But that was an important thing for our customer. MIBs take work from us, okay, from Cisco. Like we actually have to have a team that goes out and develops code for the MIB. When we do telemetry, we look at the internal data structures that already exist, and we do a simple mapping into a Yang model and are able to stream the data out. That's why we can deliver telemetry models much more easily and quickly than SNMP MIBs going forward. So that was one thing. The second picture here in the black, again, this is done by Victor here. He is the master of all things optical, as well as all things telemetry. So you could ask, he's in the blue shirt here looking pensive. Another thing, classically in optical platforms, like in a ROADM, that it's tough to get the data off that box, right? We have old-fashioned tools and technologies that go with that. In our NCS 1K product, which now runs XR, it inherits all of telemetry and all of the capabilities there, so we can stream optical PM data off as well. What else comes to mind, guys? Any other use cases that, as I'm talking about scale, data that's difficult to get, that you have a lot of data? Are there other things that come to mind? Using telemetry for using telemetry for getting latency data. It's certainly a possibility. It's like, where is latency? How are you measuring latency data? So for example, is it a tool like, is it something in the box like IPSLA? You could certainly do something like that. You know, it's interesting because I think we see much more work on using external tools to do latency checking across the network and less reliance on the router itself to do that. But absolutely, and there's some interesting work coming up with MPLS monitoring that will give us some interesting new data on latency. But yeah, if that data is on the router, we can stream it off with telemetry. So latency is one area of interest. Anything else? Okay. Everybody's favorite slide, but let me ask first if we have any questions. Okay. So let me sum up. A lot of features, really cool features that we develop, are not built for scale, right? It works great for 1 or 50 or 500, but when you get up to 100,000 or 1 million and you get up to high density 100 gig platforms, it breaks down, right? Things that work in enterprise don't necessarily work in service provider scale environments. Telemetry is not like that. I would say the only interesting thing about telemetry, and not to reinforce the notion that monitoring is boring, I love monitoring, but the only interesting thing about it is that it scales, right? That you can get a lot of data and you can get it really quickly. Now you have to be smart about it. You have to understand how to use your models and how to specify your sensor paths. You have to know which encoding to use, and maybe you do the extra work to use the compact encoding with all those extra protofiles because it gives you an efficiency of 4 to 10 times more. You have to understand how to manage your subscriptions. Put your big collections in a separate subscription. You have to know what collections are big. Rib tables are big. Okay, I'll just give you that one. And then finally, you should use events when it makes sense to use events, right? Don't get 10,000 yes, I'm up messages. Only get the one message when it goes down. And I think the other end of that is the use cases, right? If you're thinking about, I'm really curious about this telemetry stuff, I'd like to use it, don't just do it because it's new and it's cool, right? It is new and it's cool, and you get to use all these cool open source reference architecture things, and you can set it up in your lab for free, very awesome. But if your monitoring solution is working perfectly for you today, then you don't need to worry about this, right? But if there are places where there's data that you're not getting enough of it and you're not getting it fast enough, that would be a good place. If there are frequent changes to that data that you want to know about, telemetry is a good match. Or if that data is hard to get for whatever reason, like CBQoS MIB or optical platforms in the past. So that's it, you guys. That is how to deploy telemetry at scale in production, some of the lessons that we've learned, some of the ways that people are using it. I'll stay here for questions. I pointed out the people in the room that you can also talk to. Tons of opportunities to see it in action here at Cisco Live. Thank you very much for your time and attention.